introduction. I thought you were just going to say one sentence about it. Anyway, so today I'm actually representing SWAN organization, and I'm going to be talking to you about digital twin. So just to let you know what the talks are going to be, I'm going to introduce SWAN, and then introduce the concept of digital twin. It's been around for a very long time, but probably fairly new to water. I think this year showed a big shift in the understanding of digital twin. And then why is now the right time to be talking about digital twin, and then a little bit more about the SWAN digital twin subgroup that we created, and hopefully can get some of you more involved in it. So SWAN organization, I know that Ahmed said it was a relatively new organization, but it's actually been around for about 10 years. It's a nonprofit organization based in the UK, and the goal is really to raise awareness and best practices for digital technologies across global utilities. So the members include, universities, technology companies, engineering consulting companies, and most definitely utilities from around the world. So just to give you an idea of some of these companies that are current members. So if your company is not a member and you'd like to get more involved, please let us know. We'd love to have more input from the global society to make these big changes in digital technologies. So now, what do we mean by a digital twin? Just a show of hands, how many people have heard of that term and feel very comfortable with it? Okay, I would say half the room. So a digital twin, like I said, has been around for quite a few years. My first instance of it is when you think about the rockets going up to the moon or to Mars. You always say, Houston, are you there? Or you're looking at Houston, it's a bunch of computers and people sit behind us, very similar to what we have here. That was a digital twin of the rocket, so that they can constantly keep a record of what's happening with the rocket as it's going up, into the sky. So that was really an initial digital twin. Since then, digital twins have been used in the airline industry, in manufacturing, in product design, the oil and gas. I think energy also is pretty, uses digital twin concepts a lot more than water. I think in water, we're a little bit behind, but we're moving forward in this direction. So what it really is a software description or a digital description of a physical system that not only shows or represents the assets of that system, but also represents the behavior of that system or the dynamicity of that system. So if you will, it's a model of an existing system. And you can think of the hydraulic model that we use during engineering and design and expansion phases. If you take that hydraulic model and instead of using it in a static mode, start using it in a more continuous mode, and instead of input parameters based on mathematical assumptions, start putting in real-time data from real-time sensors and meters and SCADA systems as input to that simulation, and then start taking data from the real system to calibrate the system, then you have a digital twin. And it doesn't necessarily have to be a hydraulic model that represents the system, but this is a proven physics-based model that we know for the most part works if all the assets are entered properly. Some people might think of creating a mathematical model based on the output data that you get from the system. So you can also have that as your model to represent the digital twin. So that's the first, way I'd like to introduce digital twin. The other thing, so in this digital twin working group that I'll talk about in a few minutes, we had a workshop in Amsterdam a couple of weeks ago, and we introduced the concept of using digital twin as in the design phase, and then again in the construction phase, and what we have been talking about most of the time is digital twin in the operational phase. In order to use it in the design phase, imagine using something like BIM, building information modeling, for your early requirements. Early design phase, use AutoCAD to design based on the requirement, design your network based on the requirements. Then you migrate all that information with GIS to, let's say, a hydraulic model, and then you can optimize on multiple objectives rather than a few key requirements. You can optimize the system design before digging the first hole. So that's the beauty of using digital twin in the design phase, and then as you go into construction, you start getting feedback through sensors as you start to construct the network, and you use that again to optimize at each stage until you get to operations. So just to bring a real example or something that's more meaningful, so let's say you have a drinking water utility. That drinking water utility will have a SCADA system, will have a CMMS system, probably lab data from LIMS, sensor data, pressure sensor information. You would probably look at the GIS information. You might bring in weather data. All that data needs to be integrated to create the concept of a digital twin for that same system, for the same water utility. So let's say you might have a continuous hydraulic model and you're simulating that in real time using some of this data that you are integrating from your existing physical system so that you can run these simulations. And once you have calibrated a digital twin, which we're going to hear about, there are a few utilities around the world that actually have a live digital twin. One of them you're going to hear about today from Valencia, Spain, Global Omnium. But once you have a calibrated digital twin, it's not easy to get there, and it's a continuous process. It's not I'm going to go buy a digital twin and pop it in. It's a process of integrating data. It's a process of developing your model, so your model will start to behave more like your physical system, and that's on a continuous basis. But once you have that, it becomes a very powerful tool. It becomes a powerful tool for operations. Imagine doing leak detection based on the very first symptom that you could actually detect before you have a break in the pipe. You might have a blip in the pressure. You might have a change in the concentration of your chlorine that you injected into your pipes. And that little anomaly could be alerted because the digital twin is constantly looking at all of these parameters on a constant basis, multiple parameters. So now you can detect these problems early on before it becomes a failure, and it becomes cost effective to go ahead and fix the problem. So you can look at it from an operational perspective. You can then do predictive analysis. You can look into the future and do simulation with predicted data based on historical data. So you can do demand forecasting. You can use it for efficiency. You can optimize on energy. You can optimize on all your chemical dosing. So there's all kinds of things that you can do with this very powerful tool once it's up and calibrated. So why now? Why are we talking about it now in the water sector? Well, lots of things are happening, and this year seems to be a big shift, but we have utilities deploying more sensors than ever. Sensors are definitely becoming cheaper, less expensive. We're developing new sensors to detect new things that we haven't detected previously. So we're deploying more sensors. Cloud computing, I think, is one of the biggest game changer of all, because once you can start to use an elastic source of compute resources, you can then run these very heavy simulations. As I've heard from many utilities about running even a hydraulic model simulation for engineering and planning, and it takes 24 hours or something like that. And it takes a lot of compute resources, very slow. But once you go up to the cloud and your software can expand across multiple of these compute resources, it can go much faster. So cloud computing does help with the idea of digital twin. You also have artificial intelligence. More and more utilities are working with companies that can provide digital analysis to different data sets, a combination of data sets, and get more and more insights to make decisions based on the data insights. You're using more and more drones to collect different types of data. All of this is useful in a digital twin. Think of a digital twin as the culmination of all existing digital technologies. It's really bringing all that to the forefront and making it as useful as possible. Customer engagement is another big shift that we're seeing. Customers today are digitally savvy for the most part, and they're expecting way more from their water utilities than they have in the past. So how we interact with our customers, what information we can share with them, how transparent can we be, how quickly can we tell them there's a problem, and when to expect it to be resolved. All that kind of communications is going to be very important. And with digital twin technology, you're constantly monitoring, you're understanding what's happening. And of course, virtual and augmented reality have become, commonplace in manufacturing, have become commonplace in airline industry, flight simulators. We're starting to grow a generation that sees everything in terms of 3D and augmented reality. Then you have 5G right around the corner. You have blockchain technologies, and I'm sure there's going to be other technologies that are going to also push us further in towards this type of digital twin. So in essence, there's 3 key elements for a digital twin. You have to have a physical system, create a virtual system of your physical system, and then all of the data interactions, data from the physical system into your virtual system, but at the same time, the output and the insights from your virtual system can also feed right back into your physical system in terms of automation, which automation will happen at some point, but not in the early stages. I think in the early stages, we'll first gain the insights, have a human being interpret those insights, do the manual change, and once we feel that there is consistency, I think automation will happen after that. And the real ideal, which is exactly equivalent to what the SOW, those Smart One Water Center is all about really, is a complete water cycle. So imagine if we have a digital twin of your drinking water, a digital twin of your wastewater, a digital twin of the storm water, and a digital twin of the source water. And each of these digital twins are constantly monitoring and representing the behavior of each of those entities. Then you can concatenate the information. So imagine a source water digital twin is you're monitoring it and you're realizing there is more of a particular chemical that's in your rivers or in your groundwater at a particular time due to season, due to something that happened upstream. You can then inform the drinking water treatment plan on chemical dosing and be more efficient in how you treat that water based on the knowledge of what you've learned from the digital twin of the source water, and so forth. The same thing with drinking water into wastewater, same thing with storm water into your source water. And just to talk about resiliency, okay, thank you. Just to talk about, oh, I didn't even see the green. Okay. To talk about resiliency, what I've heard in the earlier panel, it really comes down to data. Coming down to collecting enough data, understanding where we are, what's happening, using historical data to predict the future so that you can better resolve the difficulty. I think the classic definition of resiliency is the capacity to resolve difficulties quicker, or how quickly can you resolve difficulties. Well, data is the key, and what we're saying with Digital Twin is this is the ultimate use of a combination of all your data sets that you're already doing. And I'm not saying it's easy, it is difficult, but it's doable. And I think this does represent the One Water Engineering Center. So quickly, I'm not gonna go too fast, we created a SWAN H2O Digital Twin Working Group. We have met twice. We're getting ready to meet for the 3rd time. We're gonna have a workshop in Glasgow in May, on May 11th. We're also having conference calls in the background, and we decided to divide up in 2 separate groups, a holistic architecture group and an outcomes and an ROI group. And we're working to develop a best practices on what does the architecture really look like and the outcomes. And I don't have time, but we did set the objectives for each of, this is the architecture subgroup, this is the outcomes subgroup, These are the members that are currently participating, so if you'd like to participate, please let me know. And here are some of the tasks and some of the volunteers that we have for the architecture, what we divided up into the 3 tasks. We did the same thing for the outcomes. We are making quite a bit of progress. It's very exciting, and we'll be able to share that on a global basis at these workshops and on the SWAN website. So if you go to the SWAN website, you'll find a lot of this information. And that's it. So thank you so much.